We've been asked to find all functions with the given derivative of y prime equals 4x cubed plus 5x squared plus cosine of 3x plus 2. The second corollary to the mean value theorem tells me that every function with the same derivative, so any function with this derivative, differ from each other by at most a constant. So if I can find one function that has this as its derivative, all of the other functions are that function plus some constant. So I really just want to treat this like a puzzle and think about where each term came from, because I know when I take the derivative of a function with many terms, I just take the derivative of each term, right, using the sum rule for the derivative. So I just want to go term by term and think about something that could be that part in the function, right, where that derivative came from. So this is a 4x cubed. I know when I take the derivative of a polynomial, the powers decrease. So this should come from an x to the fourth term. And even better than that, when I take the derivative of x raised to the fourth power, I would get 4x cubed. So that part is done. Moving on to the 5x squared part. Well, again, the power should have gone down when I took a derivative, so it should come from something with an x cubed in it. But if I take the derivative of x raised to the third power, I'd get 3x squared, not 5x squared. Well, how could I fix that? Well, I'm thinking about using the constant multiple rule. Right? If I sneak a 5/3 out front, right, I take the derivative now and I get that 3 times that 5/3 and I get 5x squared. So I'm 2 parts down, 2 to go. I'm halfway through the problem. I need a function whose derivative is cosine. Well, that should be sine. But then I think, well, sine of 3x, if I take the derivative of sine of 3x, I would get cosine of 3x, but the chain rule would apply, and I'd have to multiply by 3. And so I'd have 3 cosine of 3x, not just 1 cosine of 3x. Well, how am I going to fix that? Again, with the constant multiple rule. If I think about a 1/3 being out front, that 1/3 would just carry down to my taking the derivative, and I get that cosine of 3x. And then finally plus 2, well, that would be plus 2x. So I certainly haven't answered the question yet, because I found one function with the derivative I was looking for. Now at this point we should go through and make sure we've actually accomplished it, right? Take the derivative of each term, make sure they match up, and if not, we could, think our way through it. This is where the second corollary to the mean value theorem comes into play. This is one function with this derivative. Any function with that derivative would look just like this, except for maybe include a plus c, some arbitrary constant. This is literally every possible function that has this as its derivative. Later on in the course, we will learn some more terminology, and we'll call this an antiderivative, that we've literally found something that is the function to this derivative, right? We've done the process backwards. Instead of differentiating, we anti-differentiate. And we'll learn a cool symbol, the indefinite integral of f with respect to x. That's not what we're doing today. The only reason to mention is I don't want to see this yet. You're probably going to be able to find videos on the internet, and you might have taken part of a calculus course or seen this in other coursework. But for right now, I want to treat these just like puzzles. I just want to think our way through it. I don't want to see integral symbols yet, because we're not really talking about antiderivatives, but we are. But I want to treat these as puzzles. Just think your way through them, and don't forget that arbitrary constant. Near the end of the course, we will use the language of antiderivatives.